Hello. So over the last couple of videos, we've been talking about the trigonometric identities for the trig functions of double angles. So like the sine of 2x, the cosine of 2x, the tangent of 2x. And at that time, I had promised that the cosine of 2x, specifically the identity for the cosine of a double angle, would become important in the future, and now is when I fulfill that promise. So we found that the cosine of 2x is equal to 2 cosine squared of x minus 1, right? That's what we derived just by using the angle sum formulas. And we got this, which is interesting because it compares cosine of 2x, so just involving the first power of x, to cosine squared of x. I'm sorry, the powers of the cosines. So how can this possibly be used to our best interest? Well, what I want to do is I want to take this and I want to put it in terms of cosine squared of x. So I'm just going to solve. So we add 1 to both sides, right? We have that cosine of 2x plus 1 is equal to 2 cosine squared of x. Now we're going to divide both sides by 2. We get that cosine squared of x is equal to 1 plus cosine of 2x divided by 2. And this is the main power reducing formula, because now we have cosine squared of x in terms of essentially cosine of x, or cosine not of x, but of some function to the first power here. So what we're doing, this is power reducing because we have cosine to the second power here and cosine to the first power here. And you'll find when you get to calculus that being able to take something like cosine to the second power and turning that, making that in terms of the first power of a function, and I believe I actually have a video on this, allows you to simplify things in terms of other calculus operations in a very necessary way. Now, what I'm going to do now is, since we know cosine squared of x in terms of this lower power trig function, I'm going to find sine squared of x, right? So first let's, I'll write this where cosine squared is on the left. We have that cosine squared of x is equal to 1 plus cosine of 2x divided by 2. And we know from our Pythagorean identities that, well, let's write it out. We know that sine squared of x plus cosine squared of x is equal to 1. So, hence, sine squared of x, it's not loading there, is equal to 1 minus cosine squared of x. And what's cosine squared of x? Well, we just put that in terms of cosine of 2x, so let's try putting sine squared in terms of 2x, as I said. So let's just plug cosine squared of x in here. We'll have, and I'll switch colors for this as well. We have that sine squared of x is equal to, right, 1 minus, and we're subtracting cosine squared of x. So that would go in there. 1 minus 1 plus cosine of 2x, getting off the screen there, divided by 2. Let's just try to close it off. I have a limited screen from my end. All right, so can we simplify this a little further? I think we can. This is going to be equal to 2 over 2 minus 1 plus cosine of 2x, and I'll try not to run out of space this time, divided by 2. That's the same as 2 minus 1 minus cosine of 2x divided by 2, or 1 minus cosine of 2x divided by 2. And this is our formula. I'm going to write it out. Sine squared of x is equal to 1 minus the cosine of 2x divided by 2. So this is just another way to take a trig function of some higher power, like sine squared of x, and put it to a lower power. And you'll notice that even with our sine function to the higher power, so sine squared of x, we still used our cosine double angle formula to derive it, because you'll notice that the sine double angle formula, we can write that out too. We know that, let's use even a different color. Oh, this is going to be a weird color. Okay. We know that sine of 2x is equal to 2 sine x cosine x. And you'll notice that we cannot turn this, we cannot easily turn this into something to work with, because it doesn't already involve this second power that allowed us to make this comparison. So here we have effectively, let me circle the two important things. We've derived these two formulas, both from the cosine of 2x formula that we derived earlier, right? Well, we got this up here. I'm not going to circle that because we changed it, so whatever here. I'll get rid of that for clarity. We found, using our double angle identity for cosine of x from earlier, these two formulas that compare the higher power, so like second degree power trig functions, to single degree trig functions. And in the next couple of videos, we're going to see some of the ramifications of this and some of the other identities that we will be deriving. Thanks for watching.